So we've already talked about looking at a graph of a function and determining what the domain and range is. So I want to go a little bit further with the domain of a function and talk about what happens when you just have the rule of the function and how you can determine what the domain is. So remember that domain is the x values of a function, or the inputs, if you'd like to think of it that way. And how you want to think about this is when you're talking about the domain from a function, is what are you allowed to plug in? And so I have three different functions that are going to cover everything that we're going to talk about. And so the first one, f of x, it's just a normal looking function, the one in red here. And what you're allowed to plug in is different than what you're allowed to plug in of g of x and h of x. So just looking at the f of x one, you notice that there's no square root and no variable in your denominator like there are in the other two. And so if you see this and you're asked to say, if you're asked what is the domain of f of x, you have to think, what am I allowed to plug into this? Well, you're allowed to plug in every single value in the real numbers and everything is good to go. So I'm not going to spend any more time on that, and I want to concentrate on these two situations where you have a denominator and when you have a square root. Okay, so again, if you don't have a denominator and you don't have a square root, then you're allowed to plug in anything you want. So let's talk about these two. So I'm going to use the same example from the last slide, and then, just to drive home the point, I'm going to do one more example after that. So if you have a variable in your denominator like we do in both of these, then there is a limit on what you're allowed to put into this function. And it's not a huge thing, or there's not a ton of numbers that we're not allowed to do, but there is one specific number in both of these, or any function that has a variable in the denominator, that we are worried about. Because if you remember, you're not allowed to divide anything by zero. It's just undefined. It doesn't make sense in the real numbers. And so we can use any number except for one specific thing. Okay, and that would be, for g of x, that would be the value of x that when we plug it in gives us a 0 in the denominator. And that's the one value that we're not allowed to have. So it's very easy to figure out what that is, because all you have to do is take your denominator and set it equal to 0. And this is what this is saying. You're asking yourself, what value of x will give me 0? Okay, and it's very simple to solve for. You just solve for x. So x being 2 would be a problem, because if we plug 2 in to the x right here, it'd be 2 minus 2, which would be 0. And again, you're not allowed to divide by 0. And so for the domain, you would say, well, I'm allowed to have all real numbers with the exception that x cannot be 2. And this would be your domain for g of x. So the same reasoning goes for j of x here. We're allowed to plug in all kinds of numbers in for our domain, but there is going to be one in this case that throws us off. And again, it's whatever value of x produces a 0 down here in the denominator. And again, all we're going to do is just take whatever's in the denominator, set it equal to 0, and then just solve. And so in this case, x being 1/4 would be a problem for us. And so we're allowed to plug in any real number, so our domain would be all real numbers, with the exception of x is not allowed to be 1/4. So just like when there is a variable in the denominator, whenever you have a square root, you have issues when you're talking about the real numbers. And so I'm sure you remember that it is impossible to take the square root of a negative number and still get a real number answer. If you try this in your calculator, if you try to take the square root of -4, it's going to give you an error because there is no number multiplied by itself that will give you a negative answer. So you are allowed to have a 0 inside of the square roots. There's no big deal for that. But what you're not allowed to have is a negative number. And so we have to set up an inequality this time. And I'm going to do k of x first since it's a little simpler. But, the only thing we're worried about here is whether or not are the values of x that produce negative answers in here. And so what you can do for this is say, well, I want to know what values of x produce positive numbers or 0. Okay, and that's what this says, right? It's allowed to be 0, but everything else needs to be positive. And then you're just solving a simple inequality here. And you're saying, as long as the values of x that I'm plugging in are 7 or greater, then I will get positive answers. Anything else is going to be negatives. And so this is slightly different the way you could answer this. You would say your domain is x is greater than or equal to 7. Okay, and there's other ways to write this, but this is what I'm good with. This will be fine. So it's not all real numbers, but anything 7 or bigger. So if we move back up to h of x, we're going to do the same thing. We have to have positive values in here. And so we can plug in all kinds of values for x as long as they don't produce a negative, because again, we won't be able to take the square root of a negative number. So let's just find out what our limit is. Where does that start happening? So you write this out. 3x plus 5 has to be greater than or equal to 0. So just like in the last slide, no matter what's inside that square root, we set that greater than or equal to 0 and then just solve, and we should be able to find out where or what we're allowed to plug in and what we're not allowed to plug in. Okay, so I'm going to divide by 3. And so then we would have x has to be greater than negative 5/3. Anything below negative 5/3 is going to give us a negative answer, and so that would be bad for us. So those are the three options that you're going to want to know how to deal with.